All right, let's talk about the James Webb Space Telescope. I mean, this thing is more than just a telescope. It's a genuine marvel of engineering, and it's completely rewriting what we know about the universe. People call it a time machine with golden eyes, and for good reason. It's literally peeling back the layers of cosmic history, one stunning image after another. So let's dive right in and see how this incredible machine actually works, and maybe more importantly, what it's already found out there. You know, for as long as we've been human, we've looked up at the night sky and asked some really, really big questions. Like, what did the universe look like right at the very beginning? How did the first stars even switch on? And, of course, the big one, are we alone? Is there another Earth out there somewhere? Well, it's exactly those questions that led us to build something like Webb. Okay, so why couldn't we answer these questions before? Well, for the longest time, the answers were basically hidden from us. It's like the universe was hiding its secrets behind a veil. You see, the light from the dawn of time has been traveling for so long that the universe's expansion has stretched it out all the way into the infrared part of the spectrum, and that's totally invisible to our eyes. Plus, the places where new stars and planets are born, they're usually wrapped up in these thick clouds of cosmic dust. So to see through all that, we needed a completely new kind of eye. And that new eye is Webb. Now, this chart really drives the point home. Webb is not just a bigger, better Hubble. It's a completely different beast. I mean, just look at these numbers. The mirror is way, way bigger. It orbits 1.5 million kilometers away from us, not just circling the Earth. And check out that temperature, minus 223 degrees Celsius. That is ridiculously cold. And all of it, every single design choice was made for one reason, to see the universe in infrared light. So, why that super distant orbit? It's actually a genius move. This spot, called the second Lagrange point, or L2, is special. From there, Webb can keep the sun, the Earth, and the moon all behind its back at the same time. This lets its giant sunshield block all of their heat and light, which is absolutely critical for keeping its instruments cold enough to see faint infrared signals. Think of it like this. It's found the perfect, quiet, dark, and cold corner of the solar system to set up its workshop. All right, so let's get into the hardware. Let's look at the tech that makes this whole thing possible. Because this isn't just a telescope, right? It's a whole suite of game-changing inventions, all built to crack those huge cosmic mysteries we talked about at the beginning. 6.5 meters. That's the diameter of Webb's primary mirror. It is, by far, the biggest mirror we have ever launched into space. And size here is everything. To catch the incredibly faint light from the edge of the universe, light that's been traveling for over 13.5 billion years, you need a giant light bucket. The bigger the bucket, the more light you catch, and the further back in time you can see. It's as simple as that. So why is it gold? I know, it looks amazing, but it's not just for show. The mirrors themselves are actually made of beryllium, which is super light and doesn't warp in the insane cold of space. But that beryllium is coated with a microscopically thin layer of pure gold. Why? Because gold is one of the best materials on the planet for reflecting infrared light. That gold coating means that 98% of those precious little packets of ancient light, those photons, that hit the mirror actually bounce into Webb's instruments. Almost nothing is wasted. Okay, now how do you keep that mirror cold? That's where the sun shield comes in. And this thing is an absolute masterpiece of engineering. Imagine a 5-layer parasol the size of a tennis court. On the side facing the sun, it gets cooked to about 85 degrees Celsius, pretty hot. But here's the magic. Each layer is separated by a vacuum, and it radiates heat out into space. By the time you get to the 5th layer, where the telescope lives, the temperature has dropped to a mind-boggling minus 233 degrees Celsius. That's an incredible temperature difference. And deep inside one of Webb's main instruments, there's another piece of genius tech called the micro-shutter array. The best way to think about this is like a grid with 250,000 tiny little windows, each one smaller than a grain of sand, that can be opened or closed on command. So what does this do? It lets astronomers point the telescope at a patch of sky, close all the shutters that have bright, distracting stars in front of them, and only open the ones that are perfectly lined up with the faint, distant galaxies they really want to see. This means they can study up to 100 different objects at the same time. It's a huge, huge boost in how fast we can do science. Okay, so we've got all this incredible technology, the giant golden mirror, the massive sunshield, the tiny windows. So what? What has it actually found? This is where it gets really exciting. Let's look at the actual discoveries that are changing everything we thought we knew about the early universe. This timeline really puts it into perspective. Webb has spotted a galaxy. They're calling it JADE's GS Z14-0, and the light from this galaxy started its journey towards us when the universe was only 290 million years old. Let that sink in for a second. The universe is 13.8 billion years old. We're seeing this galaxy as it was when the universe was just 2% of its current age. It's barely a cosmic heartbeat after the Big Bang. But here's where it gets wild. According to all our old theories, a galaxy like this just shouldn't exist that early. It's way too big and way too bright for its age. The analogy of finding a fully grown adult in a baby's nursery is perfect. And then to top it all off, Webb found the chemical signature of oxygen there. Oxygen. That means an entire generation of huge stars had already been born, lived their lives, and exploded, creating heavy elements. It's completely upending our timelines for how quickly the universe got up and running. Now, Webb isn't just staring at the edge of time, it's also looking at things happening right here in our own galactic neighborhood. And in one of these stellar nurseries, a place where new stars are being born, it spotted a jet of gas being shot out from a baby star. And this jet is 8 light years long. 8! Just so we're clear on how massive that is, the distance from our sun to the next closest star, Alpha Centauri, is about 4 light years. This one jet is nearly twice that long. It's incredible. And what this discovery proves is something really fundamental. It doesn't matter if a star is big or small. When it's forming, it shoots out these giant jets. It's a universal rule of star birth, and we're seeing it in stunning detail. Okay, so we've covered ancient galaxies and baby stars. What about one of the most exciting fields in astronomy today? I'm talking about exoplanets, planets orbiting other stars. Webb is basically opening up a whole new era here, allowing us to actually study the weather on these distant worlds. Let's look at a prime suspect, TRAPPIST-1e. This is a planet that's about the same size as Earth, and it's in the habitable zone of its star, which is super exciting. Webb has been playing cosmic detective. So far, it's been able to rule out a couple of things. It definitely doesn't have a thick, gassy atmosphere like Jupiter, and it doesn't have a crushing, dense carbon dioxide atmosphere like Venus. So what's left? Well, it's either a bare, airless rock, or it might just have a thin atmosphere, maybe like Earth's, that was created later on. The investigation is still very much active. And get this, Webb has literally found a moon factory. It took a close look at this young planet, a gas giant, and saw a disk of dust and gas swirling around it, the stuff moons are made of. And the chemistry of that disk was fascinating. It was packed with complex carbon molecules. But here's the kicker. The bigger disk of material around the parent star didn't have those same chemicals. This is huge. It means a planet can create its own little chemical environment to build its moons, completely separate from its star. And then sometimes Webb finds stuff that just makes scientists scratch their heads. It looked at this weird object called a brown dwarf, kind of like a failed star. And this one is nicknamed the Accident. And in its atmosphere, it found a gas called silane. Now here's the problem. This brown dwarf is so cold, all the silicon in that gas should have turned into solid rock or clouds ages ago. It just shouldn't be there as a gas. It's a real puzzle, and it tells us we have a lot to learn about how atmospheres work on these strange old objects. So, after all that, you have to remember this is all just from the first couple of years. We're just getting started. The mission has a long, long way to go, and the future looks incredibly bright. 20 years. That's the new estimated mission lifetime. Because the launch was so perfect, the telescope didn't have to use much of its own fuel to get into its final orbit. That means it has way more fuel left for pointing and adjusting than anyone dreamed. We were hoping for 10 years. We're likely going to get 20. That's 2 decades of discovery we have to look forward to. And you can bet that every second of that time is precious. The way it works is in observing cycles. Basically, astronomers from all over the world compete. They write proposals saying, here's what I want to look at, and here's why it's important. The best ideas get the telescope time. We're already well into cycle 4, and the plans for cycle 5 are already being made. It's a non-stop global push to aim Webb at the most fascinating questions we can think of. So when you step back and look at it, in just a handful of years, Webb has already forced us to go back to the drawing board on how the first galaxies were born. It's given us the tools to study the air on planets light years away. It's revealed a universe that's more vibrant, more chaotic, and frankly, got started a lot faster than we ever thought possible. It's already reshaped our entire cosmic photo album. The only real question now is, what's the next big discovery going to be?